So, transition from user mode to kernel mode. So, this is done by means of system calls. So, in this diagram, so you can see that normally when the user processes are executing, so they are executing with in user mode with the mode bit equal to 1. So, this 1 or 0, so that is depicted by the processor designer. So, in this particular example, it has been taken that for user mode the mode bit is 1 and for kernel mode bit is 0. So, this is this may be the reverse also, and there can be multiple such mode bits also. So, this is just an example. So, user process executing, as I was telling, the normal statements that are there. So, they are getting executed by the user process, and after some time, so there will be a system call when the program needs to access system resources. So, it will be making system calls, and when the system call is made, so this is normally implemented by trap type of instructions that we have in the computer architecture. So, corresponding processor designer, so they in the instruction set normally there are some trap type of instructions. So, they are used for this purpose, and trap instructions, so they transfer control of the system to some specific addresses, and what the OS designer does is that they put some particular OS services in those trap numbers. So, depending upon the type of system call that is made by the user process, so the corresponding trap is invoked, and then this it comes to the kernel mode, and this trap instruction when it is executing. So, the system design the architecture designer, they have ensured that the mode bit becomes equal to 0. At this point it executes the system call. So, this is in a more protected environment, and you see at this part, in the kernel part, the code that the process is executing is written by the OS designer, whereas when a process is in user space, user process in user mode, then it is executing the code written by the user. Of course, there are some library routines that are there, so that can be executed in the user mode also, and that is not developed by the user. But in general, I can say that when a program is executing in the user mode, so it is executing the code written by the user, and when it is going to the kernel mode of execution, so it is executing a piece of code which is written by the OS designer. So, these codes are written much more carefully, so that there cannot be any problem, unwanted problem in the system. So, this executing system call, so it is making mode bit equal to 0, with that it is executing the system call. After the system call execution is over, it will return setting mode bit to 1, and then it returns to the returns from the system call, and that goes back to the user process execution. So, we have got this user mode and kernel mode. Many a time we need to have some timers. So, a timer is used to prevent the processes to be in infinite loop. A timer is used, which is timer is a hardware device. So, it actually so when you start a process, so how do you know that this process is taking too much of system resources? Too much of system resources, maybe in terms of CPU time, maybe in terms of some printer or some other system resource. So, how do you know that it is taking too much of time? So, for that purpose we can put a limit on the system on the processes usage of that particular resource, or a process going on to infinite loop. So, this is by means of starting a timer. When the timer expires, so it means that the process should have been over by this time, but it must be misbehaving. That is why it is giving this type of performance. So, that process may be needed to be stopped. So, normally some systems, so they put a limit on the amount of CPU time that a process can use, and when that time expires, the process gets killed automatically. So, this timer is provided by the hardware designer, that is the processor designer. It should have a timer in the system. So, timer is a counter that is decremented by the physical clock. So, we say maybe I start a timer 10 second. So, after every physical clock tick, the value will be reduced by 1, and then when the value becomes 0, then it will interrupt the computer after the time period. So, now when this interrupt comes, then we know that the process has not released the resource by this time. So, we may identify the process to be one which is misbehaving. So, operating system sets the counter by me. So, that is the privileged instruction. So, that will set for how much time the process should execute, and when the counter reaches value 0, interrupt will be generated, and then the OS will set up the value of the counter before scheduling a process to regain control or terminate program that exceeds the allotted time. So, what we mean is that suppose I have got a system that has got multiple users in the system. So, in a multi user or multi processing system, the basic requirement is that every process or every user should get the access to the CPU after some time. At some, maybe I give to be fair to everybody, we may decide that we will give 2 seconds to each of them. So, when we are doing that, so this 2 second thing, somehow the system has to know that 2 seconds has expired. So, how does it know it? So, it knows by starting a timer for 2 seconds, and when the 2 seconds is over, the timer will come, and there can be two possibilities. One possibility is that the process that was given 2 seconds does not execute for 2 seconds, it finishes before 2 seconds and comes back, or it goes into an IO operation without executing for 2 seconds. So, that may be one type of situation when we say that the process is good, its behavior is good, because it is not using lot of CPU time, it is giving other chances for execution. And the other possibility is that the process continually uses that 2 seconds and it does not stop in between. Then when this timer interrupt will come, then the OS will know that the process has exceeded, process has completely used its 2 second time. So, the operating system now regains control of the system, and then it will remove that process from the CPU and give turn to the next process that is there in the queue. And again this process will be executed sometime later when all other processes have got their turns, and again this is a turn for this process. That way it can go on. So, this timer is very important. A very important part of operating system is known as the process management. So, we will see this process in more detail, but just to tell you, a process is a program in execution. It is a unit of work within the system, and program is a passive. So, any program that I write, so it is ultimately going for execution by the system. So, that becomes a process. So, when I write a program, I have translated it into using some compiler, and I have got the machine code of it. So, machine code that is generated is kept as a executable file in the disk. So, that is a passive entity. So, that is not taking the CPU for execution, but when this program is given for execution, so the user wants to run the program, then the program is loaded into main memory and it starts executing. So, it starts consuming CPU time and all. So, now the process, now it becomes active. So, if I say that the program is a passive entity, process is going to be an active entity. Process needs resources to accomplish the task, like it needs CPU, memory, IO files, etc. Whereas a program, it just resides in the disk. So, it is just taking some disk resource, nothing more than that. There is some the program or the process will need CPU, memory, IO file plus some initialization data, some data variable will be required, some they are to be initialized to some values and all. So, that will be required. Process termination, when a process terminates, then when it was executing, it held a number of resources. So, when the process terminates, all these resources are to be taken back by the system, and maybe it is now used by some other process. So, process termination requires reclaiming of any reusable resources. We will be talking about thread in more detail later, but a thread is a basic unit of CPU utilization within a process. So, within a process also there can be several sequences of executions that are possible, and it may so happen that a number of sequences they go parallelly. A typical example is like this. Suppose I have got a server, some web server, and there are a number of requests coming from different users of the system. Now, all of them are executing the same server program, but within that every user or every client that connects to this server has got a different entity. So, all of them are called threads. So, in this sense, a thread is the basic unit of CPU utilization within a process. For a single threaded process, instructions are executed sequentially one at a time until completion. So, this type of thing is a single threaded process, and process. So, if you look into a process that has got a program counter that specifies the location of the next instruction to execute. So, that is very general for any system, any program that we have to execute. So, this processor will have a program counter register that will tell like which instruction to execute next. Compared to single threaded processes, we can have multi-threaded process in which one program counter. So, we have got one program counter per thread. So, as I was telling that there can be several threads for that web server program, and then for each thread I need to remember which statement I was executing. So, in some sense you can say we have got multiple program counters for one for each thread. Typically, a system will have many processes, some user and some operating system processes, they are running concurrently on one or more CPU. So, this is the most general scenario. So, we can have some user programs and some user processes and some system operating system processes. So, they will run concurrently, and there may be a single CPU, there can be multiple CPU. So, depending upon the scheduling policy, so these processes are given to these CPUs and then they are executing. So, their concurrency has to be maintained. So, concurrency is done by multiplexing the CPUs among the threads. So, if I have got say 4 CPUs and there are 10 processes or 10 threads, then I cannot execute all 10 of them simultaneously, but I can take up 4 of them, give to 4 CPUs, 4 cores or 4 CPUs. Then after some time I take back these 4 and give another set of 4 threads for execution. So, that can be done. So, that way there is a concept of time multiplexing among the threads. So, process management activities, operating system is responsible for these activities. One is creating and deleting user and system processes. So, when the operating system comes up, so it creates some processes, and whenever the user programs come up, they create some processes. After some time, some of these processes will die. So, we have to delete them. So, that creation and deletion of processes. So, that is an important responsibility of operating system process management module. Then we may want to suspend a process or resume some process. So, as I was telling that a process may be taking lot of CPU resources or IO resources like that. So, how to take the how to stop one process executing, and if I stop it in between, then maybe I need to restart it later. So, what is the how do you suspend it and how do you resume the operation? Then how to provide mechanism for process synchronization. So, I must do something so that I can synchronize between the execution of processes. So, it may so happen that I have got an application where I have got 2 processes P1 and P2, and it is the case that this P1 this P2 it uses some value which is computed by P1. So, it is required that in my system though P1 and P2 they are 2 parallel processes or parallel threads. So, P1 should be executed first and then only P2 should be executed. So, there is an explicit synchronization requirement between P1 and P2. So, in a more general case, I can think that a system has got a number of processes in it, and there are some synchronization requirement, like say if this is say P1, P2, P3, P4 like that, then it may so happen that P4 it requires P1 and P2 should be over. There is another process P5 that can be executed only after P3 is over, and there is a process P6 that can be executed after this P4 and P5 both are over. Now, how do you ensure that this type of synchronization? So, if I create 6 independent processes and give it to the system, then say how to ensure that system will not execute P4 before P1 P2. So, that is the synchronization problem. Sometimes we need some mechanism for communication, like say some data item which is computed by P1 is used by P2. So, there must be some communication mechanism between the processes, and there is a typical problem that occurs whenever you have got this type of multiple processes which are known as the problem of deadlock. So, deadlock is a situation where none of the processes can proceed and system throughput will be very low, because all the processes they start waiting for data computed by each other, or all of them start waiting for some resource to be freed by some other process, and that process again waits for some other process to finish its resource. So, ultimately all the processes they go into a cyclic situation, and then we have got a system situation where the entire system in the entire system nothing is progressing. So, that is a deadlock situation. So, we will see it in more detail when we go to the discussion on deadlock. So, this is the responsibilities of this process management part. Then there is another module in the operating system which is known as the memory management module. So, here the job is to execute a program, all of the instructions must be in memory. So, this is the first thing. So, for executing a program, the program must be in the main memory, because CPU can talk only to the main memory, it cannot talk to the secondary storage like that. So, the program must be there in the main memory. So, ideally the entire program be in the main memory, or it may so happen that entire program cannot be loaded. So, there will see some schemes in which we will find that even if we load a part of the program, so they can be it can be executed by the system, by the CPU. So, this is the first requirement. Second requirement is that all of the data that is needed by the program must be in memory. So, apart from the program code, so all the data part should also be there in the memory. Memory management determines what is in memory and when. So, it has to decide, like this is we have got the requirement that for executing an instruction, the instruction code must be there in the memory, and the variable on which this instruction operates, that must be present in the memory. So, the memory management policy, so it has to decide that for smooth running of all the processes, which are the program segments that should be there in the memory, which are the data segments that be in the memory, and at what time those values be available. So, if a program is not executing now, so it is not mandatory that I should have the corresponding program and data variables loaded into the memory. So, the memory manager may decide, no, I will not put this part in the memory now, I will use this space for loading the data and program for some other program which is currently being executed. So, that way the memory management will decide what should be there in the memory and when should it be in the memory. So, memory management activities, so they talk about keeping track of which parts of memory are currently being used and by whom, deciding which processes and data to move into and out of memory. So, and allocating and deallocating memory space as needed. So, these are the major responsibilities of memory management. So, operating system design, if you look into, so they can be divided into a number of modules. So, one of them is the process management module that we have seen its responsibilities in the last slide. So, this slide is telling us, like, for a memory management part, so this is another responsibility of the operating system. So, what are the essential jobs that it has to do? Then we have got the storage management part. So, OS will provide a uniform logical view of information storage. So, when a program is executing, so it is not understanding whether the program the content is coming from main memory or the content was not there in memory, it is coming from the secondary storage. So, it will not understand that, but as the physically the program may be, some part of the program may be in the main memory, some part may be in the secondary storage and all that. So, logically whole thing is a single storage, main memory, CPU register, then your disk. So, they are all part of this logical storage. So, this access to this logical storage is uniform. So, program when it is executing, it sees everything as memory location and it just tells that I need the content of this particular memory address, and that OS has to see like whether that is available, and if it is available it will give the value. If it is not available, then it has to get the value fetched from the secondary storage and then return the value. So, this way we have got different storage management problems. So, this storage management modules, they will abstract physical properties of logical storage unit. So, that is called a file. So, it will consist of a set of files, and whenever it has to access some memory location, so maybe ultimately it has to look into a file. So, files will be stored in a number of different storage medium, it may be in the disk, maybe in the flash memory, maybe in the tape. So, innumerable different storage media that I can have for storing the files. and each medium is controlled by device drivers. So, each device is different, like the operation of a disk storage is not the same as the operation of flash memory. So, but as an OS designer, so if we want to have different views for each of them, so designing operating system becomes complex. So, what is done? We have got the device drivers that can talk to the corresponding devices, and that makes the access to all these devices uniform. So, as OS designer, it has to send messages to the disk driver, this device driver, and this device driver will in turn translate it into commands specific for the device. So, that way from the OS viewpoint, so this is an uniform view. So, as you go so that the uniform view is provided by the device driver, and at the next level the device driver, so they will have the interface to the devices, and that will provide the exact commands for doing it. So, there can be varying properties that can include access speed, capacity, data transfer rate, access method, etc. For example, the disk, so there the access is random. So, disk head can be moved to any place, and the disk can rotate and the head can go to one place. Whereas, for tape type of device, so there the access is sequential. So, if you have accessed location x, at the next time the head will be at position x plus 1 only, then at x plus 2 only. So, that way it goes by location. So, that way the tape access is sequential, whereas disk access is random in nature. Capacity wise, if you say, then tape capacity may be huge, but the disk capacity may not be that much. So, data transfer rate again, so disk will be better than tape. So, like that, or the storage is there, but the storage management becomes an issue. So, we have to think about the policies by which we can take care of this difference in speed and difference in behavior of these modules and all. So, this will be talking about the file system management. So, files, this is another module of the operating system that we have. So, files are usually organized into directories or folders. So, access control on most systems to determine who can access what. So, access control is a set of rules that will say like who is allowed to access which file. So, this is very important because when you have got multi-programmed system or multi-processing system, so multiple users are there. So, one user should not willingly or unintentionally modify some other user's program code or file etc., or data like that. So, whether that is happening or not, so OS should provide some control over that. So, file management policy, so that uses this access control mechanism to do that. So, OS activities in file management system, it includes creating and deleting files and directories, primitives to manipulate files and directories, mapping files onto secondary storage, backup files onto stable storage media. So, when a program is executing, all on a sudden it may try to open a file. So, that facility has to be provided. Similarly, a program may want to read or write into the file. So, that facility has to be provided. Then for organizing the files into a proper structure, directory structure may be provided. Then given a file name, how do I locate it? So, maybe in some directory I have got a file. Now, in the physical, if it is a disk storage, so ultimately it does not have that directory and everything there. So, what it has is some sector addresses, that file starts at some sector address. So, how to locate the sector address for a particular file? Like a program has asked me to ask the computer to open file XYZ. Now, what is the corresponding disk sector number, that has to be known. So, that is the problem of mapping. So, mapping file name onto the storage address. So, that is one important thing to be done, and sometime so we need to take backup. So, because if there is a system crash and all, then all the contents will be lost. So, it is the requirement that we have got some backup of the system in some stable storage. So, the secondary storage management part. So, usually disks are used to store data that does not fit in main memory, or data that must be kept for a long period of time. So, they are kept in the disk. Then proper management is of central importance, because the disk is much slower than main memory. So, when I say that some part of my data did not fit into main memory, so that is why I have kept it in the secondary storage, then I must ensure that when the data is needed, that is taken back into the main memory, and that has to be done a bit efficient fashion, because if I start accessing the secondary storage when that particular data is referred to, that may increase the access time. So, if I can be a bit proactive, so if I can just get the data a bit earlier, then we can find that data in time. So, that way this storage management becomes an important issue, and when do you get the data from the secondary storage to the main memory. So, that is a problem. So, proper management is of central importance. Entire speed of computer operation hinges on the disk subsystem and its algorithm. So, the disk access is a very important problem that we will see when we come to the disk management portion. So, as far as OS activities are concerned, so it includes free space management. So, files are getting created and deleted from the system. So, that creates some free spaces on the disk. Now, after some time, that entire disk may be fragmented into these small free spaces that we have. So, that stops us from using all these free spaces together. So, this free space management is a very important issue. Then storage allocation. So, how do you allocate disk for a to a process that wants to create a file. So, that storage allocation is a problem. Then disk scheduling. So, this talks about if there are multiple requests to access the disk from different processes, then in which sequence we provide those accesses, because this is an electromechanical device. So, disk head movement will take time. So, if it has to go from track number 1 to 10, then it will take some good amount of time for doing that. So, if I can schedule all my requests in such a fashion that this movement is minimized, then I will get a better performance from the system. So, this disk scheduling is an important problem. Some storage need not be fast, like the tertiary storage like optical storage, magnetic tape, they need not be very fast, but like capacity should be huge, and but still they need to be managed by the OS or applications. Then we have got the concept of cache memory. So, this is important, this is an important principle, because data may be kept at several levels and cache is something that is closest to the CPU. So, that way when this cache is accessed, then maybe if the data is available in the cache, then the main memory access or secondary storage access, so that can be avoided. So, that way I can have performance improvement. So, it provides faster storage, and if the cache size is small, then naturally the cache size will be small, because the cost of the cache is high. So, which data you store in the cache and how do you access it. So, that will determine the management policy of the cache, and that will be determining the performance of the system. So, if we look into various levels of storage, then CPU registers typical size is less than 1 kilobyte, cache it is 16 megabyte, main memory 64 gigabyte, then solid state disk 1 terabyte, magnetic disk less than 10 terabyte, like that. So, size is actually increasing in the direction from register to magnetic disk. On the other hand, implementation technology, there are different implementation technologies. Access time is an important factor. So, if you see that access time of this CPU registers, so they are very small, in the range of in the range of nanoseconds, whereas if you go to magnetic disk, so this is becoming pretty high. So, that is there. Bandwidth, how many megabyte per second you can transfer. So, the CPU register it is the highest, and as you go to magnetic disk, so it is low. So, depending upon the type of data that you have and how important it is, how frequently it is needed. So, you may decide the level at which you will be keeping that particular data. So, this is this decision has to be taken by the operating system. Next we have so this is the migration data from hard disk to main memory. So, this I have already discussed, and this cache coherence problem that can come, because the data item should be consistent across all the levels. Then we have got this IO subsystem. So, we have got this the IO devices are there in the system. So, as a user of the system, so we should not be looking into this each IO device separately. So, I should have an uniform interface. So, the operating system should provide me a facility by which this uniform IO device access can be made. Then there are protection security mechanism, as I already said that protection has to be provided by the operating system. So, that for multi-processing system, so I should not be getting multiple users, one user should not be getting access to the data by other user or program of other user. Similarly, security has to be provided in terms of user IDs and all. So, we will be going to these security protection issues later. So, to conclude, so operating system, it acts as an interface between computer hardware and users. It makes the system usable in a user friendly manner, controls usage of different hardware and software resources in a computer system. So, we have discussed about what is an operating system, and we have seen that the specific activities that are there are process management, memory management, storage management, protection and security. So, in successive classes, so we will be looking into this thing one by one and continue with that.